Hello everybody. Once again I am here with you for the another session which is to be related with the same real gases and their behavior is to be there, and we are looking for the Boyle's temperature. Although the title is only by Boyle's temperature, the two points we are covering here. The first one is to be related with the same as an Boyle temperature's relationship is to be there. The behavior of real gases at high pressure is to be there. Actually, both these points, that is Boyle's temperature and the behavior of real gases at high pressure, is to be correlated with each other. Amagat's already given the experimental results at high pressure, what happens and what he got exactly related with the different gases. The result already we have seen how this at low temperature, what happens at high temperature, how the whatever be the pressure is going to be increasing, pressure and volume product is also going to be increasing. Let's see what happens exactly here with the in the combination with the Boyle's temperature is to be there. So here is the summary diagram we can say as far as the different gases are to be there. And here we are looking for the pressure volume versus pressure relationship is to be there. Along the x-axis there is a pressure, and along the y-axis there is a pressure, and the volume is to be there, product is to be there. And for the different gases, the what exactly the graph is to be there, it is shown in this case. So the general nature behavior of the gases is the same for the all the gases, as the PV and the P relation is to be there, but somehow the variation is to be there with the temperature part and let's see what exactly basically related with this part. If you look at the some curves are the straight one to be as an showing PV as an what to be the pressure is going to be increasing, PV as also to be in the same constant way is to be there. So some of these are to be giving us to be decrease, and reaching at certain level goes on increasing, at the pressure is going on increasing, pressure and volume PV is also going on increasing. So these are some differences, and somehow what the things are to be there which are showing us these variations are to be there. Basically at low temperature these variations are going to be occurring. So as far as the PV versus P relationship is to be there, sorry, let's see the what exactly if the temperature of the gas is high, the value of PV increases with the increase in the volume is to be sorry, in the pressure is to be there. So if you look at for the higher range, that is to be as an for high temperature cases are to be there, PV is going on also increasing with the P is to be there. So it will happen only for the higher pressure. But as far as the lower pressures are to be there, lower temperature is to be there, it is somehow giving you different differences are to be there. If high temperature is to be there, the PV is also going on increasing with the P is to be there. But at the low temperature, if you, these are the graphs where it is to be showing for the higher temperature, it is P and PV is also goes on increasing for the high temperature. But as far as the low temperature, so let's see what happening to be here in this case. As far as the low temperature is to be there, the PV decreases with the increase in the pressure, and these graphs are showing clearly that here if you look at, this is somehow decrease is to be there, as the pressure is going on increasing, this PV is going on decreasing is to be there. So but this will continue for the lower temperature, but it will attain some certain value, and then afterwards it's also going on increasing gradually with the P. That is to be PV is decreasing for the P with the P, but at lower temperature. they will reach at certain level and then again going on increasing with the pressure. Now this will happen only at the low temperature, and that is somehow for the critical temperatures relationships are to be there. Means that there is a conversion factor as far as the liquefaction is going on at that stage, because these all these variations, this decrease in the PV is to be there up to the critical temperature. Means lower temperature, but what is that lower temperature? For the critical, those are at the stage of below the critical temperature, the PV goes on decreasing at that stage. It will reach up to certain level where the liquefaction of the gas is going on, because we know that at the below the critical temperature the gas is going to be converted into liquid, and that is what the critical temperature is to be there. In this case, PV is also goes on decreasing up to certain level where the your critical temperature is to be there. Above that, again the PV is also goes on increasing with the pressure is to be there. So this is what the case where the it is giving you this type of the output. If you look at the same thing is to be as an about the outputs are to be concerned. If the temperature of the gas is low, the value of PV decreases with the increase in the pressure. PV attains minimum value and particular pressure. At particular pressure, if the pressure is increased further, the PV also goes on increasing is to be there. So whatever be the at the critical temperature, this variation is to be decrease of the PV is going on, and then afterwards there is increase in this PV with the P after the liquefaction limit is to be above the critical temperature relationships are to be there. After that liquefaction is going to be completed. So this is what the case where the particularly PV goes on increasing with again go with the increasing the pressure. Now the shaded part in the figure is the region of liquefaction is to be there. So this is what the shaded dotted parts are to be there. This if you look at this case where it is to be as a dotted lines, if you look at this region here, it is to be where the liquefaction is to be there. This what the dotted lines are to be shown. I am showing here with the red lines, and there the only liquefaction takes place, and after that liquefaction part there will be increase in the PV with the P is to be there. Likewise this and this so on is to be there. So this is what the case where the variation with the PV and P is to be there. But at this stage, suggestions from the Keon suggested an empirical relations based on the observation of Andrews and Amagat's what they performed their experiments, and Holborn is also studied on this different gases behavior is to be there at different temperatures and the pressures are to be there. So they have the relation with this considering these three of the scientists, and the whatever be the relation they found, that is to be they can write PV is equal to A plus B P square plus CP cube plus D P raised to 4. So here the A, B, C, D are nothing but to be a constants different for the different gases are to be there. And as these relationships comes with the real gas equation is to be there, and state that is PV is equal to RT relationships are to be there. But for the different gases it is different relation, means there is to be as an A plus BP square plus CP cube plus DP raised to 4 is to be there. And these ABCDs are constants are nothing but to be called as a virial virial coefficients are to be there. And the constants depends on the temperature. These constants are totally dependent on the temperature, and sorry, and these values of A, B, C, D as having negative value at a certain stage, and then afterwards it becomes 0, and then it will comes to the positive. So the important factor is, as these factors, sorry, the constants, coefficient constants are to be a, b, c, d at the negative stage, as well as they will come to as in positive, and then afterwards to be as an zero, and then afterwards to be positive is to be there. But the important factor is the zero, where these at temperature at which these values are becoming to be as an zero, that is very important. And these variables are going to be zero, that b is to be zero is called your Boyle's temperature, where the b is becoming to be as an zero, where the pv and p remains to be as a constant at that stage. And that is what exactly we are interested, that Boyle temperature is to be there. Pressure and volume is going to be constant. For the constant pressure is to be there, so either you are increasing the p, their pv will be constant, and that is what the b is to be zero, and that is nothing but to be called as a Boyle temperature is to be there. So at Boyle temperature, no doubt, the pv is equal to a, that is constant is to be there. So 0 is not meaning to be as an value will become 0. 0 meaning is to be there is no change in that pv, that will remain constant. It is the meaning 0 is to be nothing but to be a constant is to be there. ती व्हॅल्यू 0 होत नाहीये, याचा अर्थ असा आहे की ती व्हॅल्यू कॉन्स्टंट एकसारखीच राहते. आपण समबडी असेल की लहानपणापासून त्याची उंची वाढतच नाही, तेवढीच आहे, दॅट इज कॉन्स्टंट. झिरो नाही झाली त्याची हाईट, काही ना काहीतरी फिक्स हाईट आहे कोणाची, पण ती वाढलीच नाही, दॅट इज व्हॉट रिमेन्स कॉन्स्टंट. इट इज नॉट मिनिंग टू बी झिरो, बट द झिरो मिनिंग्स no change, that is the constant is to be there. So pv is equal to a, in that case b is equal to dpv of dp is to be there. This is what the relation is developed with the differentiation relation developed with the Boyle temperature is to be there. B is equal to dpv upon dp is equal to 0. Why it is to be 0? Because there is constant. We already said this ratio pv by p will be constant, there will be no change, and that's why dpv by dp is equal to 0 is to be there. So Boyle temperature, the gases sorry, below the Boyle temperature, the gases are highly compressible. It is already, we have in the Amagat's experiments also it is shown that the below the Boyle temperature, the gases are highly compressible, which shows that the existence of the intermolecular attractive forces between the gas molecules. So this is quite interesting thing is to be there. See, in general, we know that wherever the gas molecules are in agitation stage, means इकडून तिकडं फिरत राहतात कंटिन्युअसली मॉलिक्युल्स, गॅस मॉलिक्युल्स. पण आता ही कॉम्प्रेसिबल स्टेज म्हणजे कसं की जे लिक्विड थोडंफार येतात आणि त्यामुळे त्यांच्यामध्ये लिटल बिट फोर्सेस ऑफ अट्रॅक्शन इज टू बी शोन. म्हणजे जेव्हा फोर्स नाही अट्रॅक्टिव्ह फोर्सेस, त्यावेळेस ते रँडमली इकडं तिकडं ॲजिटेशनमध्ये मूव्ह होत राहतात. पण ह्या केसमध्ये जेव्हा बिलो Boyle temperature, the compressibility of that gas are to be too a little bit higher, and due to that there will be a more forces of attraction in between the molecules, gas molecules are to be there. And that is what the stage is to be, they are showing the intermolecular forces in between, working in between the gas molecules are to be there. Above the Boyle temperature, gases obeys the Boyle's law, that pv is equal to constant for the pressure is to be there. Intermolecular attractive forces are least significant, very least significant are to be there. So and this is what the behavior of the real gases at the high pressure is to be there, and related with the Boyle temperature part is to be there. That's why we have given the title Boyle's temperature is to be there. Now we have that stage where the Boyle temperature is to be there, and b is equal to dpv upon dp is equal to 0. That stage is nothing but to be your Boyle temperature stage in equation point of view, we can say. Now it is the temperature at which the real gases behaves like ideal gases and obeys the Boyle's law. And we have the chaos relation, that is to be pv is equal to a plus bp square plus cp cube plus dp raised to 4 is to be there. This is somehow we can give it to be as an equation number 1. At Boyle temperature, b is equal to 0. We know that pv is equal to a dpv by dp is equal to 0 is to be there. So this is what the relationship. But we have van der Waals equation of the state. We will learn in the next point also, or in the next class, how this van der Waals equation of the state is to be there. Because as far as the real gas equation, we know that pv is equal to rt, but van der Waals suggested correction in that real gas or ideal gas relationship, pv is equal to rt, and he stated that p plus a by v square into v minus b is equal to rt is to be there. So this is what the corrected by van der Waals ideal gas relationship is to be there. How it will come, that we will see in the next lecture is to be there. So here according to the van der Waals equation of the state, we have this relationship is to be there, which is to be as an p plus a by v square into v minus b is equal to rt is to be there, where a and b are the constant, p is nothing but to be your pressure, v is nothing but to be volume, r is your Rydberg constant, and t is nothing but to be your temperature is to be there. So here little bit trigonometric adjustments or the summations are to be there. And if we multiplied with this p with this equation v minus b, then we will get pv. I will make it a little bit larger to understand it clearly. So here is to be the case. Love likewise this. So p into v, that is pv, again p into minus b, that is minus pb, plus now this a by v square will be multiplied with this bracket, and this will be nothing but to be given with the values are to be here as an a by v square into v. That's why 1v and this square means 1v get cancelled and a by v will be remaining. So that's why the value will be a by v minus again a into b by v square is to be there, minus this is equal to rt as it is. So again we need to find out relation pv is equal to, that's why pv is equal to this side will go to right hand side. मग pv इज इक्वल टू जर लिहायचं असेल मला, तर हे सर्व काही आहे ते राईट साईडला जाईल. मग ऑलरेडी राईट साईडला कोण आहे, आर टी आहे, प्लस मग हा पी बी मायनस आहे तर इथं प्लस होऊन जाईल राईट साईडला गेल्यावर. हा ए बाय व्ही प्लस आहे तर हा इथं मायनस होऊन जाईल ए बाय व्ही. हा ए बी बाय व्ही स्क्वेअर मायनस आहे तर हा इथं जाऊन प्लस होईल. So PV is equal to, I can write RT plus PB minus A by V plus A B by V square is to be there. So this is what the new relation we have at this stage, and this relationship is to be somehow written here to be as an in this fashion. So but again real gas or the ideal gas equation, we know that PV is equal to RT. According to that I can make changes. Let PV is equal to RT, then according to that V is equal to, this is what the PV is equal to RT. जर पी व्ही इज इक्वल टू आर टी हे असेल तर त्याच्यावरून व्ही इज इक्वल टू आर टी बाय पी असं लिहिता येते. सो दिस पी विल गो हिअर राईट साईड. सो पुटिंग दिस व्हॅल्यूज ऑफ व्ही व्हॉट वी हॅव, आता व्हीच्या जागी काय टाकायचे, आर टी बाय पी, म्हणजे इथं व्ही आहे, इथं आपल्याला आर टी बाय पी, आणि इथं व्ही स्क्वेअर आहे, इथं पण आपल्याला आर टी बाय पी व्हॅल्यू पुटअप करायची आहे. मग हे रिलेशन काय होते, पी व्ही इज इक्वल टू, आय कॅन राईट आर टी प्लस पी बी मायनस, आता ए ॲज इट इज डिवायडेड बाय व्ही, म्हणजेच काय, व्हीला रिप्लेस काय करायचे, आर टी बाय पी इज टू बी देअर. मग ए बाय आर टी बाय पी म्हणजे डिवाइड बाय डिवाइड, मग तो मल्टिप्लिकेशनमध्ये येईल, म्हणून काय होईल, मायनस ऑफ ए पी बाय आर टी, प्लस इथं पण तसंच होईल, ए बी ॲज इट इज राहील, डिवायडेड बाय व्ही स्क्वेअर म्हणजे काय, आर स्क्वेअर टी स्क्वेअर बाय पी स्क्वेअर, डिवाइड बाय डिवाइड म्हणजे इट कम्स टू बी भागिलेला भागिले गुणिलेमध्ये कन्वर्ट. So it will give us AB into P square upon R square T square is to be there. So this is what the relationship we have. आणि ह्याला रिशफल करून ह्याच्यामध्ये जर बघितलं तर ह्या इक्वेशनमध्ये आता P जर बघितलं तर सगळीकडे कॉमन येतो. मग हा P जर कॉमन काढला तर पी व्ही इज इक्वल टू, आय कॅन राईट आर टी प्लस पी इंटू बी मायनस हा पी इथं गेला ए बाय आर टी प्लस ह्या फक्त ह्याच्यामधून हा पी कॉमन काढला, प्लस ए बी पी स्क्वेअर by r square t square is to be there. So this is what the new relation I have. And now considering these equation 1 and 2, comparing, this is what the equation 2, ह्याला जर equation 2 म्हणलं आणि equation 1 तर आपल्याकडे ऑलरेडी आहे, पी व्ही इज इक्वल टू ए प्लस बी पी स्क्वेअर प्लस सी पी क्यूब प्लस डी पी रेज टू 4 is to be there. So comparing these two, what we have, a is equal to आर टी. सरळ सरळ इथं बघा, हा जो पार्ट आहे दिस आर टी पी व्ही इज इक्वल टूच्या केसमध्ये आपल्याला बघायला मिळेल इथं हे इक्वेशन ए मध्ये ए आहे, पी व्ही इज इक्वल टू. मग ह्या ठिकाणी ए इज इक्वल टू काय होईल, आर टी, आणि बी इज इक्वल टू काय होईल, बी इज इक्वल टू व्हॉट वी हॅव द रिलेशनशिप इज टू बी देअर. ते दुसरा पुढचा जो पार्ट आहे, हिअर बी इज नथिंग बट टू बी इक्वल टू this part is to be there. So b minus a upon rt is to be there. So this is what we have for that b is to be there, coefficient constant is to be there. So b is equal to this a is equal to rt and b is equal to small b minus a by rt is to be there. And for the c, ab by r square t square is to be there. But as the temperature is called to be as an Boyle temperature, at that stage Boyle temperature, we can say the T is nothing but to be represented with the T suffix B, that is Boyle temperature. And at the Boyle temperature we know B is equal to coefficient 0 is to be there. Therefore in this case again what we can write, this b is going to be 0 in that stage. Therefore we can write this b minus a by rt is equal to 0, because both are left hand sides are equal. In that case b minus small b minus a by rtb is equal to 0, because t becomes tb is to be there. So boil temperature in that case can be represented as, जर हा इकडे गेला तर it is nothing but to be, म्हणजे या केसमध्ये जर आर टी बी मला रिप्रेझेंट करायचं असेल तर दॅट इज सिम्पली नथिंग बट टू बी इन दॅट फॅशन, टी बी इज इक्वल टू ए बाय आर बी इज टू बी देअर. सो हाऊ इट इज टू बी द केस, हे जर बघताल तर ह्याच्यामध्ये हा राईट हँड साईडला जर गेला बी इज इक्वल टू ए बाय आर टी बी येते. म्हणजे ह्या केसमध्ये जर समजा ह्याला मी सॉल्व केलं, हाऊ द टी बी इज कमिंग टू बी ॲज अन इन दिस केस, म्हणजे हे अचानक टी बी इज इक्वल टू असं का लिहू शकतो, तर इथं केअरफुली बघा. तर ह्या केसमध्ये मी बी इज इक्वल टू स्मॉल बी इज इक्वल टू ए बाय आर टी बी असं लिहू शकतो. मग हा इकडं जाऊ शकतो आणि हा इकडे येऊ शकतो, म्हणजे मल्टिप्लिकेशन हा टी बी जर इकडे गेला तर टी बी कॅपिटल बी इंटू बी इज इक्वल टू ए बाय आर, मग हा बी इकडे जातो, मग ए बाय आर बी इज टू बी देअर. So in this case I can write TB is equal to A upon R small b is to be there. So this is what the Boyle temperature's relationship is to be there. And Boyle's temperature for the different gases are different, and here are to be as an N2 nitrogen, for this Boyle temperature is 50 degrees centigrade, for the hydrogen it is minus 169 degrees centigrade, and for the helium it is minus 254 degrees centigrade. So this is what the Boyle temperature is to be there. And we can calculate the Boyle temperature of different gases, and we have seen for the different gases this Boyle temperature is different. So this is what for the Boyle temperature and the behavior of the real gases or the gases at the higher pressure is to be there. This is what the case where it is to be as an behavior of the gases of the real gases are to be there. Thank you for joining this session. Be at home and be safe. Thank you.